Hello, and welcome back for more pseudoscience. Because as we all know, science is a whole lot of BS. With that said, math is also BS, because science is using it all the time. What is that? 1 plus 1 equals 2. Get the F out of here, you brainwashed NPC. Today's theme is Coriolis, and why it is pure BS. Because as we all know, you can't just start a plane on a globe without getting blown away by 1000 miles per hour fast winds. Or jump without Earth turning away below you. So the Earth must be flat and stationary. There is no other way. Okay, stop. Everything stop. How embarrassing. Sorry, I forgot to turn my brain back on. I was shitposting before you came here, so I had to hurry and forgot it. But now for real. Today's theme is the Coriolis effect, and why it is not BS, with the use of common sense. But first, a definition. Rule of motion conservation. Matter with a mass stays by nature in the current state of motion or stillstand, as long no asymmetric outward force acts on the matter of mass. This is a reason why you are getting pressed into your car seat if you accelerate. Because your body is in a lower state of motion, and it wants to keep this state. Vice versa when you are getting decelerated. Matter with mass, that is in motion, will always follow a straight line, if not influenced by something. This is a reason why you are getting pressed to the side when you enter a curve. Your body wants to keep going straight, but is being forced to change the direction. The strength of the force pressing you aside depends on your speed and the angle of the curve. Here we encounter one of the arguments of the flat Earth. The claim is that they can't feel the motion of the Earth. Earth has a perimeter or extent of whopping 40,030 kilometers and 174 meters and is doing one rotation in 24 hours. So far nothing new to you, right? Then let's do the math. This is how you calculate the speed. As you can see, we get a value of a distance over time. Speed is not a force. It is just stored energy that will get converted into physical work in one or another way. Speed is by nature a state of no change and requires an asymmetric outward force to be altered. This is reason 1 why you can't feel the motion of Earth. Because there is no change in motion you could feel. But since Earth is rotating, there should be something you could feel, right? Because your body is being forced to change direction with Earth. Why are you not flying away? Let's see, shall we? The centrifugal force that we experience is calculated by dividing the velocity to the power of 2 by the radius. This gives us a centrifugal force of 0,337 meter per second squared. A force is always in meters per second square, which happens to be an acceleration. Do you know what is also an acceleration? Gravity. As a side note, gravity is not a force in the traditional sense, but for us, it is acting like one. And the value for the gravitational acceleration is 9,81 meter per second squared. Gravity is around 29 times stronger than the force that wants us to catapult into space. And this is a reason why our world, even if spinning, looks like this. And not like this. Like flat earthers think to know and try to argument, and not even doing the math. It took me like 5 minutes to look it up and understand the formula for acceleration. And it boils down into comparing two values with each other. It is really not that difficult. You can do that too. It is easy. But I guess it becomes infinitely harder if you don't trust the formulas because of your science equals bad bias as a flat earther. And back to the question of, if you can feel the centrifugal force of Earth's rotation. What do you think? If you just stand around, can you feel yourself getting lighter, or do you feel your weight? I don't know how it is for you, but I start to feel my feet getting uncomfortable after standing for some time. Sitting is just as good to make my point. You surely will feel how your butt is getting pressed against your chair. Now with this knowledge in the head, we can stomp the next flat earth argument in the line, which is why planes don't get blown away by 1000 miles per hour fast winds. Make yourself ready for a big and unexpected mind blow. The atmosphere has mass, and Earth's surface is everything else but smooth. Also, don't forget, our planet and its atmosphere were born in a rotational motion. And even if the atmosphere was not rotating in the beginning, Earth would have dragged the atmosphere with it. It is the same like with a mixer that you hold into water. The water/air gets dragged along. I don't know what is so difficult about this to understand. If it would not be a thing that gases and liquids are getting dragged along, then mixers would be useless, don't you think? But now in detail. Our first frame of reference is the surface of Earth. Here we see a plane taking off and flying for some distance. The plane has its one speed, one velocity, with which it flies forth and back. Now we go to the next frame of reference, which is in space following the orbital position of Earth. Here we see how Earth is rotating, and how everything else is rotating with it. The plane has still its own speed, its one velocity. But now we see that this was not completely right. The actual speed of the plane was the speed of the rotation plus/minus its own speed. This is the reason why speed is relative, and why there is now such thing as total speed. You never know what else is outside of your frame of reference. The conservation of motion is also the reason why Earth will not be rotating away below a helicopter. The helicopter has the speed of Earth's rotation, just like the atmosphere. There is zero reason for it to be blown away or suddenly being left behind. The conservation of motion is also the reason why a battleship does not have to target a position in the future for the bullet to hit. Because the bullet is not suddenly separated from Earth's frame of reference. Seriously, why should it suddenly lose all that kinetic energy that it has from Earth rotation, just because it exits a barrel? Nonsense. Now we go to the next bigger frame of reference, which is looking at the solar system. Here we see that the plane has not just one, not two, but three different speeds. Speeds of the same direction are getting added. Speeds of opposite directions are getting subtracted. I hope I don't have to say that my models here are not to scale, if it wasn't obvious enough. The point is to demonstrate what frames of reference are. I hope this video made it easier for you to understand what is meant when someone is talking about frames of reference. It is the question of, with what the observer is moving along, and in what relation this is standing with another movement they observe. And for the question of why pilots don't have to point down the nose of the plane. The air is getting thinner the higher you go. The plane has a weight. The plane is also moving with a certain speed. And the atmosphere has a pressure gradient. The combination of speed and weight creates a certain amount of upward force on the wings. This combination is in a balance with the thinner getting atmosphere. At some point, is the atmosphere not thick enough anymore to support the weight of the plane with its current speed? This is also the reason why planes sack down when they hit an air hole. An air hole has less pressurized air than where the plane was before, so it sinks down to a height where the thinner air can support the plane again. No magic required here. The plane is following the curve because it has no other choice than to obey the pressure of the atmosphere. And with that, goodbye.